I urge you to please subscribe to our YouTube channel, like and share our video, as we promise to be bringing you more interesting presentation on subjects relating to Utme, especially physics. Thank you. Now, for today's presentation, we shall be talking on hydrostatic, specifically density. I am Bangwade A. Now, before we proceed, we need to consider the learning outcomes of this presentation, which goes thus. Listeners should be able to define density of a substance. They should also be able to state the formula for calculating density. Then they are expected to be able to state the instrument for measuring density. And lastly, they should be able to solve relevant UTM questions relating to density. Now, on density, by density we mean the mass per unit volume of a substance. Therefore, density can be defined as the mass per unit volume of a substance. Mathematically, density D will be equal to mass m over volume V. I repeat, density D will be equal to mass m over volume V. Its units can be gram per cm cube or kilogram per meter cube. I repeat, the unit of density can be gram per cm cube per centimeter cube or kilogram per meter cube. Now, density can be measured by hydrometer, by an instrument called hydrometer. Density can be measured by an instrument called hydrometer. And lastly, we should note that the density of water is 1 gram per cm cube or 1000 kilogram per meter cube. I repeat, the density of water is 1 gram per centimeter cube or 1000 kilogram per meter cube. Now on to sample questions from UTME. And the first question we shall be considering comes from 1979, number 1. And the question goes thus. The density of 400 centimeter cube was 0.9 gram per cm cube before frying. If the density of the oil was 0.6 gram per centimeter cube after frying, assuming no loss of oil due to spilling, its new volume was dash. So we have option A to be 360 cm cube, option B to be 600 cm cube, option C to be 240 cm cube, while option D is 800 cm cube and option E is 450 cm cube. Now on to solution. We have to recall that the density equals mass over volume, that is D equals m over V. Now we can make m the subject, which is the mass. So if we make m the subject, that will give us m equals, by cross multiplying we have m equals density times volume. Since they said no loss of the oil, that means the mass before frying will be the same as the mass after frying, the mass of the oil after frying, and therefore we can find the expression for the mass of the oil before frying, and it will be equal to the mass of the oil after frying. And that is what we are trying to do here now. So before frying, let's represent the density of the oil by D1, which is, according to the question, 0.9 gram per cm cube. Then the volume also will be V1, which is 400 cm cube. Then after frying, let the density of the oil after frying be D2, and that will be 0.6 gram per cm cube. Then the volume of the oil after frying will be V2, which is unknown, and of course that is what they ask us to find. Now, since the mass of the oil before and after frying is equal to each other, then the expression for it will also be equal, and therefore d1 phi1 will be equal to d2 phi2. Then in substituting for the parameters, our d1 is 0.9 times phi1, which is 400, equals d2, which is 0.6 times phi2, which is unknown. Now we can make phi2 the subject by dividing both sides by 0.6 to get phi2 equals 0.9 times 400 divided by 0.6, and that will give us phi2 equals 600 centimeter cube, making option B the correct answer for this particular question. Now the next question we shall be considering comes from 1990, number 14, and the question goes thus: 40 meter cube of a liquid P is mixed with 60 meter cube of another liquid Q. If the density of P and Q are 1.00 kg per meter cube and 1.6 kg per meter cube respectively, what is the density of the mixture? So you have the option A to be 0.05 kg per meter cube, option B to be 1.25 kg per meter cube, option C to be 1.30 kg per meter cube, while option D is 1.36 kg per meter cube. Now on to solution. We have to record that the density D equals mass m over volume phi. Then we can make m the subject by cross multiplying to get m equals d times phi, that is density times volume. Now let's go to our parameters. We are given the density of liquid P, which is represented here by dP, to be 1 kg per meter cube. Then we are given the volume of liquid P to be 40 meter cube. So phi P here is volume of liquid P, which is 40 meter cube. Then also we are given the density of liquid Q, which is represented by dQ, and that is 1.6 kg per meter cube. And lastly, we are given the volume of liquid Q, which is represented by phi Q, to be 60 meter cube. Then from m equals d times phi, we can apply the same thing here to get MP, that is mass of liquid P, will be equal to dP, that is density of liquid P, times volume of liquid P. So MP equals dP times Vp. Then if you substitute for that, our MP will be dP, which is 1, times Vp, that is a volume of liquid P, which is 40. So 1 times 40 will give us 40 kg. Similarly, if we apply the same thing for liquid Q, that will lead us to mq, that is mass of liquid Q, equals density of liquid Q, which is dQ, times volume of the liquid Q, which is phi Q. If we substitute for that also, our mq will be dQ, which is 1.6 times phi Q, which is 60, and that will give us 96 kg. Now the total mass represented by m total here will be the mass of liquid P plus mass of liquid Q, and that will be m total equals mp plus mq, giving us 40 plus 96, and that will be 136 kg. Similarly, we can find the total volume represented by phi total to be the phi P plus phi Q. That will give us 40. The phi P, the volume of liquid P, is 40 meter cube plus the volume of liquid Q, which is 60 meter cube. That will give us 100 meter cube. Now that we know the total mass and total volume, then we can get the total density of the mixture, which will be equal to the total mass divided by total volume. That will be m total divided by phi total, and that will give us 136 kilogram divided by phi total, which is 100 meter cube, and eventually that will give us 1.36 kilogram per meter cube, making option D the correct answer for this particular question. Next question we shall be considering comes from 1993, number 3, and the question goes thus: an object of mass 400 gram and density 600 kilogram per meter cube is suspended with a string such that half of it is immersed in paraffin of density 900 kilogram per meter cube. The tension in the string is dash. You have option A to be 1.0 Newton, option B to be 3.0 Newton, option C is 4.0 Newton, while option D is 5.0 Newton. Now on to solution. So the first is to write out the given parameters, and the first thing we are given is the mass of the object, which is 400 gram. We can convert that to kilogram by dividing it by 1000, and that will give us 0.4 kilogram. We are also given the density of the object, D naught, to be 600 kilogram per meter cube, and the density of the paraffin oil to be 900 kilogram per meter cube. Then we have to recall that the density equals mass over volume. Therefore, the density of the object dO will be equal to mass of the object mo over volume of the object pho. Then we can make the mass the subject of formula by cross multiplying to get dO pho equals mo. That is, the density of the object times volume of the object will be equal to the mass of the object. Then we can make pho, the volume of the object, the subject of the formula by dividing through by the density dO to get pho equals mo over dO. Then if we substitute for that, the volume of the object pho will be 0.4, that is mo, which is 0.4, divided by dO, which is 600, and that will give us 0.00067 meter cube. But we have to recall that from the question they said half of the object is a mass, and a particular object will display its own volume of the liquid in which is a mass. That means the volume will be half here now. So, and half of the volume will now be half of the volume we just got. That will be half of 0.00067, and that will give us 0.00034 meter cube. Then for us to get the mass, you can get the mass of paraffin MP will be equal to the density of paraffin dP times phi p, and that will give us MP equals density of paraffin dP, which is 900 kilogram per meter cube, times volume of paraffin displaced, which is 0.00034, and when we multiply that we get 0.3 kilogram. But you have to recall, from our previous video, when you want to get a weight, which is a form of force, you multiply it by acceleration due to gravity. Therefore, the weight of the paraffin here will be mass times g, that is m times g, and that will be m, which is 0.3 kilogram, times g, which is usually 10 meter per second square, and that will give us 3 Newton, making option B the subject of the making option B the correct answer for this particular question. Now the next question we shall be considering comes from 2003, number 3, and the question goes thus: a test tube of radius 1.0 is loaded to 8.8 gram. It is placed upright in water. Find the depth to which it will sink. Find the depth to which it will sink. Then you are given option A to be 2.8 centimeter, option B to be 5.2 centimeter, option C to be 25.5 centimeter, option D to be 28 centimeter. Then you are given the acceleration due to gravity G to be 10 meter per second square, and the density of water to be 1000 kilogram per meter cube. Now on to solution. The first is to write out the given parameters, and the first thing you are given is the radius, which is 1 centimeter. Then the density of water to be 1000 kilogram per meter cube, or 1 gram per centimeter cube. You know, we discussed that during our elementary stage of the presentation. Is either you use 1000 kilogram per meter cube or 1 gram per cm cube for density of water. Then we are given the mass of the tank, that can be represented by MT, to be 8.8 gram. Then you have to record that the density equals mass over volume. So in this case, you have the density of the water will be equal to the given mass over the volume. Then you can make the mass the subject by cross multiply, and that will give us M equals D times phi. Then you make phi W, that is the volume of water, the subject of formula by dividing through by dW to get VW equals M over D. VW equals M over D. We can now substitute. If we substitute, then our VW, that is the volume of water, will be the mass, which is 8.8 gram, divided by the density of water, which is 1 gram per cm cube, and that will make our volume of water to be 8.8 centimeter cube. 8.8 centimeter cube. But we have to recall that the test tube is a cylindrical object, is cylindrical in shape. So the volume of the test tube will be assumed to be the volume of a cylinder. And for the formula for volume of cylinder is pi r square. So we can now equate this to the volume we just got. So pi r square will be equal to 8.8 centimeter cube. Then when we substitute, that will give us 8.8 equals pi, which is 3.124, times r square, which is 1 square. It can be written as 1 times 1, then times h, which is unknown. Then we can make h the subject by dividing through by 3.142 to get h equals 8.8 divided by 3.142, and that will give us 2.8 centimeter cube, making option A the correct answer for this question. Now on to practice question. The first question we have for your practice there comes from 2010, number 17, and the question goes on: the density of a certain oil on frying becomes 0.4 kilogram per meter cube when its volume is 20 meter cube. What will be its initial volume when its initial density is 0.8 kilogram per meter cube, assuming no loss of oil due to spillage? So the expected answer here is option A, which is 10 meter cube. Then the second question we have given you here comes from 2013, number 15, and the question goes thus: what volume of alcohol will have the same mass as 4.2 meter cube of petrol? So the expected answer, you are given the density of alcohol to be 8.4 times 10 raised to power 2, and that of petrol to be 7.2 times 10 raised to power 3. Expected answer is 3.6 meter cube. That is option C. Now, our next video will be on relative density with sample questions and solution from Utme. I urge you to please subscribe to our YouTube channel, like and share our videos, as we promise to be providing you more interesting lecture relating to Utme. Thank you.